In this episode of lecture series, we're going to talk about dams and hydraulic structures. I'm going to introduce you to different types of dams in construction, design consideration, and a lot more. Join me as we go with this. You can see design of hydraulic structures. Now, in this case, we're dealing with dams. First, we'll give you the introduction, classifications, advantage, disadvantage, site selection of dams types. What is a dam? A dam is a hydraulic structure, fairly impervious material built across a river to create a reservoir on its upstream side for impounding water for various purposes. It may be for irrigation, for recreation, for animal, for domestic use, for recreation purpose, various uses, animal and the rest. A dam and a reservoir are complement of each other. Dams are generally constructed in the mountainous ridge of the river where the valley is narrow and foundation is good. Generally, a hydropower station is also constructed at or near the dam site to develop hydropower. Dams are probably the most important hydraulic structure built on the river. And they are very huge structure and require huge money, manpower, and time to construct. Above all, it needs techniques. These are different types of dams. As you can see, that so you can see these are different dam spaces. Okay, different type of dams built across the river. Okay, so the type of dams includes we have embankment dams, we have arc dams, gravity dams, we have buttress dams. And in these classifications, you can see that based on hydraulic design, we have the overflow, then we have the non-overflow dams. Non-overflow and then the overflow dams. You can see this is overflow, this is non-overflow. Based on the functional side, we also classify dams as storage dams, tension dams, diversion dams, debris dams, cover dams. A temp dam constructed for facilitating construction. It is enclosure constructed around a site to exclude water so that the construction can be done in dry. We can classify dam also based on the materials of construction. So there are masonry dams, mason dams, concrete dams, earth dam, rockfill dam, timber dam, steel dam, combined concrete, earth dam, composite dams. Based on the rigidity, the rigid dam is quite stiff. It is constructed with steel materials such as concrete, masonry, steel, and timber. These dams deflect and deform very little when subject to water pressure, hydraulic pressure, and other forces. The non-rigid dam is relatively less stiff compared to rigid dam. And the dam constructed on earth, rockfill, and non-rigid dams. There are relatively large settlements of formation in the non-rigid dams. So rockfill dams are actually neither fully rigid nor fully non-rigid. These are classified as semi-rigid dams. In this classification, based on structural location, we have gravity dams, we have embankment dams, earth dams, rockfill dams, arc dams, and buttress dams. Others are steel and timber dams. And as you can see, the types, material, section we are talking for this dam, gravity arm, which is the concrete masonry, rubber, concrete, and also timber and steel and earth rock for embankment. So this classification of dams resists the water. The gravity dam resists water pressure and other forces due to its weights of gravitational force. Usually made of cement, concrete, and straight in plan, while approximately triangular in cross-section with apex at the top. In the past, the gravity dams were made of stone, solid, microdam structural height of 226 meters. Was the highest concrete gravity dam of the world when built, surpassing 2.1 meter high over dam in the USA. At present, it is second highest after Grandism Dam in Switzerland, about 248 meter high. Konya Dam, Rihan Dam, Sardans, Sarova Dam, etc. A few examples of concrete dams. Nagarjuna Sagar Dam, 125 meters, is the highest masonry dam of the world. These are just a sample of the concrete dams built across the world. So the gravity dam, forces acting on gravity, various and forces acting on gravity dams may be water pressure, lift pressure, pressure due to earthquake forces, steel pressure, wave pressure, ice pressure, stability force, the weight of the dam itself. Gravity dams have some advantage. Gravity dams, quite strong, stable, and quite suitable, can be constructed at very great heights, are well adapted to use in overflow spillway sections. Earth dam cannot be used as an overflow dam. Even in earth dams, the overflow section is usually a gravity dam. So are usually suited on certain areas where there is a very high dam, or the slope of the earth dam might be washed away in such an area. So there are advantages of these gravity dams. Maintenance cost of gravity dam is very low and does not fail suddenly. There is enough warning for the imminent failure, and the valuable property of the human life can be saved to some extent. It can be constructed in all gravity conditions. Sedimentation in the reservoir using gravity dam can be somewhat reduced by operation of the system. Disadvantaged gravity dam grade heights can be constructed only on sound rock foundation. These cannot be constructed on weak permeable foundation on which earth dams can be constructed. Initial cost of the gravity is usually more than the earth alone, and the sites where good earth is available for construction and funds are limited, earth dams are better. So usually take a longer time construction than earth dam, especially when mechanized plants for batching, mixing, and transporting concrete are not available. Require more skilled labor than that in the earth dam. Subsequent rising is not possible in gravity dam. An earth dam is made up of earth, soil, and the resistant forces exerted on it mainly due to shear strength of the force. Are usually built in the wide valley and flat slab of the flat sediments and can be homogeneous when the strength of the height of the dam is not great. Of zone section with an impervious zone called core in the middle and relatively impervious zone called shoulders, enclosing the impervious zone on both sides. Nowadays, majority of the dam constructed are on this dam. The highest dam of the world are earth dams. In Russia, which we call Rogansky in Russia. Rogansky in Russia, which is about 325 meters, and Urek Dam, Russia, 370 meters, as well as the largest capacity dam in Carolina, Cornella Dam, USA. And then there's another. So these are examples of earth dams. You can see the major building here is the this earth, which are used to build the embankment. Then sometimes the crest of the dam can be used as a rock. Okay, so these are some examples. Now you can also see the earth dam design. This is really very important. Even that you can see that this is the minimum freeboard of 0.8 meter, and then riprap So it's really a good one to have a problem for this. And then the top width should just about 3 meter width, which rod can be constructed also on the top width. So there's also this depth may vary over the site from approximately 0.7 to 2 meter. Okay, which is this will be the area, the lock, you can say, which is excavated towards the same core and the dam. And the slope, can give it 1:2. And for the upstream side of the embankment is ripraping. You can see the boulders. This is a kind of key, to hold the embankment, and also the places and canvas embankment, layer of remove this side. So the tall drain and all these things to help stabilize the dam embankment. This is another embankment which you can see that this is the core of the area. This is core of the area, which is normally used for the cut of trench, which is the core that hold the embankment. There's the upstream, there's the downstream, and then just below a obvious embankment with a drain and there's a long parallel there on the side. So these are very good design. So what are the advantages? Usually cheaper than gravity, can be constructed on almost all type of foundation, can be constructed on relatively short period, skill level is not required, construction of an half dam, and can be raised subsequently. This is kind of more pleasing than gravity. So these are some of the advantages. Disadvantage, are not suitable for narrow gauges with steep slope, cannot be designed on air overflow, cannot be constructed on regions with heavy downpour. Internal cost of earth dam is very high, sluice cannot be provided high earth dam to the field, and also fell suddenly without any sign of failure. So let's talk about the rock-fill dam. Rock-fill dam is built on a rock fragment and boulders of large size. Impervious membrane, dry rubble, side slope of rock are usually equally an angle repose of the rock. And then rock-fill dam are quite economical, where large quantity of rock is usually available near the site. Mica Dam, for example, in Canada, Chicosen Dam, Mexico, are some of the highest rock-fill dams. These are examples of rock-fill dam. And it's a pretty good hold a large amount of water. So here we have the impermeable face rockfill. Look at the structure of the embankment. This is very steep with slope, reinforced concrete membrane, coarse dump rock, and so on and so forth. You can also see the impermeable half core, clay core, which is a grout cutting. So the roll rock is 0.2 meter down to 1.5 meter, then graded transition sections at the top, which usually give it a very strong business. So what are the advantages of rock-fill dam? Rock-fill dam have almost same advantages as gravity dams as discussed, but particular advantage and disadvantage of earth dam are quite inexpensive. Rock-fill are easily available, can be constructed quite rapidly, can better withstand a shock due to earth dam. So disadvantage of fill dam require more strong foundation than earth dam. Rock-fill dam require high heavy machinery for transporting, dumping, and compacting rocks. So these are some of the. So we have earth dams. You can see the structural design for the earth dams. Why is it called earth dams? It is called earth dam because it's have a curving plan with a convexity towards the upstream side and transfer water pressure or other forces mainly to the abutments by action. It's quite suitable for narrow canyons section of triangular and comparatively thinner, may have a single curvature, and also are subjected to a large stress because of changes in temperature shrinkage. And examples of such arc dam around the world are Chukuri Dam in about 272 meter high, the Russia Violet Dam in Italy, and then Mount Vuisin Dam about 237 meters in Switzerland. So these are examples of, as you can see, this is an arc dam. Now this is another arc dam. Now the disadvantage of arc dam, as we said, is an arc dam requires less concrete compared to gravity dam, essentially the thinner. An arc dam may require suitable to narrow V-shaped valley having very steep slopes. Public pressure is not important factor in the design of an arc dam because of the arc dam has less width and reduction in width due to uplift. Uplift does not affect suitability. What are the disadvantages? The dam requires good rock interference. The arc dam requires sophisticated formwork, and the arc dam cannot be constructed on very cool climate because it's earlier concrete occurred due to freezing and thawing. The arc dam are not more prone to sabotage. The speed of construction is relatively low. So now let's look also at the buttress dam. Buttress dam are of three types. You have the deck type, you have the multiple arc type, and then the massive head dam type. And the deck type buttress dam consists of a sloping deck supported by buttress. Okay, so buttresses are compression members. And the deck is usually in a reinforced concrete slabs supported between the buttress, which are usually equally spaced. And in multiple arc type buttress dam, the deck slab is replaced by horizontal heads, and then in a massive headed type buttress dam, there is no deck slab. Instead of the deck, the upstream edge of the buttress are flat to form massive heads to span distance between the buttress. This is an example of a buttress dam. You can observe the buttress in the back of the dam. At the back of the dam, these are the buttresses, okay, that holds the embankment. These are the buttresses. So buttress dam is really very, so you can see. While this is the upstream side of the embankment. So what I'm saying is that yes, you can see the illustration of the buttress dam. These are the illustrations which are very to hold the hydraulic pressure and also to pin down the embankment against any failure or shaking in case of earthquake. So you can see the cutoff for the buttress dam and the buttress mat foundation. The mat on a flat slab. So this is pretty good for. Now, what are the advantages of buttress dam? Buttress dam require less concrete than gravity dam, uplift, and it can be constructed relatively weaker foundation. Powerhouse water treatment plant can be housed between the buttress. Yeah, and so it can be designed to accommodate moderate movement of foundation without serious damage. Wow. So the disadvantage normally we look at the buttress dams require costlier framework, reinforcement, and more skill level. Consequently, the overall cost of construction will be more than that of a gravity dam. Buttress dam are more susceptible to damage and sabotage. Buttress dam cannot be constructed on very good gravity because of spiral housing and because of the upstream deck slab. Thin deterioration have very environmental. A dam is a huge structural requirement. So now let's look at the size selection of the dam. You look at you consider fans, you consider the extreme case you're taking while selecting the side of the dam. A wrong decision may lead to excessive cost and various factors. So you look at this, you look at the topography, the suitable foundation, good site for reservoirs, spillway site, availability of material, accessibility, healthy surrounding, minimum overall cost, and other considerations. Selection of the most suitable type of dam in particular site require a lot of judgment and experience. It's also a exceptional case that most suitable type is obvious. And various factors govern the selection of the type of the dam. So selection of the type of the dam, topography, valley, diversion problems, geology, foundation, availability, construction material, overall cost, length of height of the dam, roadway, life of the dam, spillway size, location, earthquake, miscellaneous considerations. But this and so on, considered in developing the system. So this is just few of the overview of the dam development, site selection, and different type of designs of the dam and where they are found, the height, the advantage and disadvantage. So in our next episode, we're going to talk about the real hydrology of the design, the hydraulic consideration, and the real design of dam structure. Thank you, and see you again in my next episode.